So now we are in lesson 2.5. First part in this lesson we are talking about functions transformations. So I'll give you a function and you're going to deduce the graphing of different functions from this function. The first part that you're going to do here is how do we graph absolute value of f of x and f of absolute value of x from the figure given from f of x. First, when I say absolute value of f of x, it means all the values of y are positive. When you replace x by any value, the answer that gives me for x, it's gonna give me a positive answer for y. So it means all the values of y are positive. So first I draw f of x as it is, so I draw it. And then what should I do? Then the part where y are negative, I change it as y positive. So how are you gonna change this y as positive? We're gonna reflect it with respect to x prime or x, because when we are below x prime or x, it means that I have y negative. So this part that is below, I should put it above. It means I need to reflect it across x prime or x. So how are we gonna do that? So if it's given like this, you have this is function f of x, okay? This is f of x and this is x3 minus 4x. If I want from this graph to deduce the graphing of absolute value of f of x, it means when you replace x by any value, the answer that should be given should be a positive answer, a positive y. So all the positive part where y is positive on the graph, I need it. So this and this I need it. Which part I cannot have it? It's this part where y is negative. It's impossible to give me a negative answer for y. But for example, for x1, it will not give me any more minus 3. It will give me 3 if you replace x by 1 and its absolute value. If it's going to be absolute value of minus 3, so it's 3. So I'm going to reflect all this part with respect to x prime or x. So this point going to be here. So all this part going to be reflected with x prime or x. It's going to be here. And this negative part here also is going to be reflected into x prime or x. And then now this yellow part represents the absolute value of f of x, or the drawing of absolute value of f of x. Now, if I want to move to draw f of absolute value of x, so to graph it, you ignore what I wrote here. You ignore the part of the graph where x is negative. Guys, x cannot be all the time. X is gonna be a positive. Yani for the part where x is negative, when I put the absolute value, the answer gonna change. It's gonna be a positive answer. So where x is negative, it will not give me a value of y as it is in the graph. For x negative or x positive, both will give me the same answer for y. So and then I use where x is positive, and I will do the reflection with respect to y prime or y. What does it mean? So if this is the graph, I'm still there. When I say f of absolute value of x, guys, if you replace x by 1, okay, or x by minus 1, it's gonna give me the same answer, because when I replace x by, let's say 1 or x minus 1, both should give me the same answer. Let's do it. If you replace x by 1, so here the function is like this, so it means now it's not anymore the same one. It's f absolute value of x, so it's equal absolute value of x is 3 minus 4 absolute value of x. Yeah, if I replace x by 1, absolute value of 1, it's 1. 1, 3 minus 4, it's minus 3. And if I replace x by minus 1, absolute value of minus 1, it's 1. Minus 4, absolute value of minus 1, it's 1. So the answer is a 3. So it means 1 gives me minus 3, sorry, and minus 1 gonna give me minus 3. So in this case, I will ignore the part where x is negative. So where x is negative, all this, I need to ignore it. So this one doesn't exist anymore. So where x is positive, all this one, it's gonna give me the same values of y. It means for x2 and x minus 2, both gonna give me the same answer. For x1, it's minus 3, and for x minus 1 also, it's minus 3. For this point and this point, it's the same. So I will reflect it across to x prime or x, and this one gonna be the graph, so it's not really well done with my hand. So for example, let's say this point is here, it's gonna be here like this. So and then a little bit far like this. I'm not being able to draw it. Okay, that's it. Okay, so I ignore all the part of the graph where x is negative. Well, now for x is negative, it will not give me a different answer than when x is positive. When x is negative and x is positive, both gonna give me the same y. Look at this. 1 for x1, y minus 3, for x minus 1, y minus 3. So for x, for example, this point here and this point here, both they have the same value of x. So when I need to draw f of absolute value of x, I ignore from on the graph all the part where x is negative. I ignore it. I just look at the part where x is positive and I reflect it across to y prime or y. In this case, I will get, as I wrote here, I will get the graph of this one. Now let's move to how we're gonna graph f of x and its inverse, 1 over f of x. So is reciprocal, sorry, inverse f minus 1. So domain is not the same. Why it's not the same? Because here I will have a fraction, and a fraction is defined when the denominator is not equal to 0. So in this case, the domain of definition of the 1 over f of x gonna be the values that makes y 0 for f of x. So those values where the denominator is 0 are called the vertical asymptote. So first of all, with the denominator is equal to 0 gives me the vertical asymptote. How are you going to find the horizontal asymptotes? It's y equal to 0 because the degree of the numerator is less than the degree of the denominator. So the horizontal asymptote is y equal to 0. I will give you a remark here about after this one about the horizontal asymptote. Let me finish now. Now, the minimum value of f of x will be the maximum value of 1 over f of x, and also vice versa. If f of x has a maximum, it's going to be a minimum for 1 over f of x. Where f of x is positive, 1 over f of x also going to stay positive, and when it's negative, it's negative. How are we going to draw it? Let's take our time to do that. Now, before I do that, let me just write this remark. I wrote it. How do you find the horizontal asymptote? As a reminder, I look at the degree of when I have a fraction. So I look at the degrees. If the degree of the numerator is smaller than the degree of the denominator, so directly I have y equal to 0 as a horizontal asymptote. Because, guys, later on you're going to see the limits, and we say limit of number over infinity, it's 0, so it gives me the horizontal asymptote. When the degree of the numerator is equal to the degree of the denominator, I will take the highest over highest. Example, if I have this is a rational function, it's the same degree. So what is the highest degree here? It's 2x over x. I simplify. So the horizontal asymptote becomes y is equal to 2. And when the degree of the numerator is bigger than the degree of the numerator by 1 degree, be careful, 1 degree. It means that, for example, I have x squared and x. In this case, I have something called oblique asymptote. Also, we'll see it in the next chapters. Now let's move to draw the graph. So I need to draw f of x equal x times x minus 4. So that's a quadratic equation. And then I need to draw 1 over f of x. First, I know that this is a quadratic function. The vertex is minus b over 2a, f of minus b over 2. I took it from this one here. And we draw it. We know how to draw it. So I did it. It's here. So this is f of x equal x times x minus 4. How we will draw 1 over f of x? First, I look at the denominator. This one gonna give me the vertical asymptote. What is the first one? X equal to 0. X equal to 0, it means it's y prime or y. So this is my first vertical asymptote. What is my second vertical asymptote? It's x equal 4. Excellent. And I have a horizontal asymptote. What is my horizontal asymptote? It's y equal to 0. That's it. And now, as I did in the preceding video when I was doing, so I have in this part, I need to draw either here or here. And in this part, either here or here, so I can take points to draw it. So for example, for x minus 1, let's see. If x is minus 1, what's gonna be y? Minus 1 times minus 5, it's minus 1 over 5, so it's positive, so it's here. So it means that this part is here. It's here, guys. So it means that this part is here. You're going to ignore all the blue part. This is not the graph. Now, in this part here, so also I need to take point bigger than 4 for x equal to 5. Also, the point going to be up here, so I will draw it here. The picky part is here between. Now, as I said, the minimum going to be the maximum. So it was minus 4, gonna be minus 1 over 4. So this point gonna be here, guys, and then this part, it's a vertical asymptote, gonna come from this part here to the maximum and go down. Also, if I want to be more accurate with the graphing, I need to take more points. You can take, for example, x1, x3 to be more accurate with the graphing. And now the red one represents the graph of 1 over x. then the green one was f of x. Let's move to the last part in this video, how to graph f of minus x and minus f of x. This is very easy. Now, if I have f of x and I want to draw f of minus x, it means x becomes minus x. So it means I need to do the reflection with respect to y prime or y. Here is x, here is minus x. So what I'm doing here, I'm reflecting across y prime or y. If I want to draw minus f of x, it means I have y and minus y. How do we do it? Where is y? This is y here, this is minus y here. So I did do the reflection with respect to x prime or x. It's very simple, this part. Now, let's say this is f of x, and I want you to draw f of minus x. So we said f of minus x, it means x, if x is positive, it's going to be x negative. And if it's x negative, it's going to be x positive. So it's a reflection with respect to y prime. Or how are we going to do it? We're going to be very careful. We start from this point. This point, where is its reflection here? How many square? That is 2. So I move 2. So it's here. The point where it's on the y-axis, stay there. So this one is here. Excellent. The 4 here becomes minus 4 here. I'm almost there. I'm almost there. Look at it, guys. Now, this one, it's going to be here. For example, this point is going to be here. This point is going to be here. So I have it like this. And then the other part here, I can reflect it. Look, I have 1, 2, 3, 4, and a little bit. 1, 2, 3, 4, and a little bit. And that's it. The orange represent, this one is f of minus x. So I did the reflection with respect to y prime or y. If I want to do the minus f of x, it's a reflection with respect to x prime or x, because here I'm changing the y. The y negative going to become positive and vice versa. So this one minus 4 going to be at 4. Okay. I should be careful for the graph. Those going to stay here. They will not change because they are on the x prime or x. This part going to be down. So for example, this point going to be here. And I'm almost there. Look at it, guys. So that's it. For example, this point gonna be here. There is 3 boxes. It's here. And then, guys, I continue graphing it properly, and that's it. So the purple one, it's minus f of x. So every time I need to do minus f of x, I do reflection with respect to x prime or x, and f of minus x, reflection with respect to y prime or y. That's it for the moment. In the next video, we will see more transformations for the functions.